Raharjo. Okay, my name is Agus Budi Raharjo. I'm lecturer from Department of Informatics, and today I will be responsible for hosting this webinar. And I'm glad to welcome Prof. Muhammad Kafafu, who will present an interesting topic, AI for health. So, before we start, let us pray according to our religion and belief. Prayer begin. Thank you. So, please do the presence before we start to make sure that you will get the certificate of attendance. And now, I would like to invite Associate Professor Bu Hastin Fatiha to give welcome speech from Department of Informatics. Bu Hastin Fatiha.
Okay. Thank you.
The Zoom is yours.
Yeah, thank you, Dr. Agus. Good afternoon, everyone, to our Honorable Prof. Muhammad. Thank you very much for your willingness and time to give the lecture, our guest lecture, and sharing your knowledge and research to our students. And I think your topic about AI for health will give us insight how to build an innovation research or a good research. So we look forward for further collaboration with you, your laboratory, and your university, Aix-Marseille, right? Aix-Marseille University. Okay, in this afternoon, we open the webinar with saying Bismillahirrahmanirrahim, and I turn time to Dr. Agus Budi Raharjo. Thank you very much.
Thank you very much, Bu Hastin Fatiha. Okay, so here we come, the special guest lecturer from Professor Muhammad Kafafu. Salam, Prof. Kafafu, vous allez bien?
Oui, très bien. Thank you very much. Assalamu alaikum.
Wa alaikum salam wa rahmatullahi wa barakatuh. So, okay. So, Professor Muhammad Kafafu, he is the professor in Aix-Marseille University, and he's the team leader of data mining at scale, or in French we call it DANA, a Laboratoire d'Informatique et Système from Aix-Marseille University. So I think it's still morning over there. It's like 8:30, right, sir?
Exact.
Okay, thank you very much. So, okay, maybe you can start to share your screen, Mushu.
Okay.
For the participants, we will start the guest lecture. So, well relax, please keep mute, and if you have any question you can send us in the chat Zoom. Okay, Prof. Muhammad Kafafu, the floor on the Zoom is yours.
Okay, thank you very much. Thank you for organizing this event and allowing me to exchange with you on an interesting and hot topic, which is artificial intelligence and e-health. I will finish my presentation by some challenges for AI and in e-health. And one big challenge is, can I say you good morning or good afternoon? This is the big problem.
Yeah.
If we have machine with us, they must perceive the world according to what they are, according to their context, and also their cultures, their education, their belief, and what they are. So this is a big question in the future, because today machines are more intelligent, it seems, and robots will be everywhere. Devices, intelligent devices will be embedded in different objects we use every day. But the question is that a human perceive the world and the devices and the machine have a representation of the world they cannot perceive, and this is a big challenge. So I say to you, good afternoon, because it's more important that they speak the language. And I introduce myself in your word than in mine. But machine cannot do this. They say, okay, it's 8, so I say good morning. Okay, so today I will introduce and discuss with you some aspects on artificial intelligence and e-health. Okay, and just something. Okay, this is the big topic: in the context, artificial intelligence and e-health. There are several things which are the foundation if we want to discuss about this subject, which are, the first is computing, the algorithm, and intelligence. What is intelligence? Can I say that I am intelligent because I say good afternoon even if I am feeling and I am living in a country where there is morning? Problem solving and also reasoning, not only problem solving by algorithms, but reasoning using logical approach. But generally today, when we introduce artificial intelligence, we mean machine learning. So I will introduce this topic. Of course, there are some mathematical aspects. I will avoid details about, but giving some example, one example on optimization, and of course, the big problem of the data we have to use. So there are the different components of this presentation, which will be organized. And of course, as I told you, the big challenge for the near future is a human and machine collaboration, because artificial intelligence is based on computation and word representations. Humans have their own intelligence, which is based on their perception of the world and on what they are. So I would start by general introduction to just motivate this presentation, and after, from computers to intelligent machines, this is an important issue. Next, machine learning, just not to give all details about, because the field is very large. I would just introduce some concepts, basic concepts, and give some remarks about practice and foundation. After that, I will introduce artificial intelligence in healthcare and their application, and I will finish by some challenge. But firstly, e-health is evolving, but there is a general evolution of the society from Industry 1.0 to what we are doing today, Industry 4.0. So the beginning is the mechanization, and after we have electrical energy and automation, computers, the advent of computers and electronics to create machine. And now machines are doing good some jobs, but they can communicate together and take decision in an autonomous way. And also there is the advent of IoT, Internet of Things, and sensor are and will be everywhere, and we will collect a lot of data and will be big, big problem. This is the evolution of our society, and e-health is following the same. At the beginning, doctors, they don't use no digital system. They use only papers and discuss directly human to human. After that, we introduce information technologies. So digital tracking, with the advent of mobile, we can start recording, having some record students. After that, and recently, we introduce IT systems, reliable systems, and we work in real time, of course, for patient tracking. And today, we are sharing data, but not only, we are sharing experiences of the management of our health on social network, for example, or specific platforms. We have not only we as citizens, but companies and public or private organizations, they have access to data in real time. And also the advent of IoT, AI, virtual reality or augmented reality or mixed reality, and all this generates data we have to deal with, and we have to use this data to create new services and to create new value. Look at just this map, show us countries in green that they have a universal healthcare for their citizens. And we can say, and we are not surprised, for example, that United States has no universal healthcare, and also there is a desert in the world. Really, there are a lot of countries they have, and we are living today in small world. So healthcare will evolve certainly in different countries will try to do some progress and to offer new services using especially technology. But technology is not enough. The big problem of the main reason, one reason of this healthcare desert, is that there are some countries where the number of doctors is few. Really, there is not enough doctors. So we need technologies, yes, but we need also doctors and human factors to evolve and to do progress. Another point that is sensors today is for example, in a department, we can buy some platform. It's not so expensive, and using, for example, Arduino and Raspberry Pi, and we can develop real application by collecting different data from our environment or physiological data to analyze different parameters of given patient or humans. So it's easy and no expensive, and the students and professors can try to really drive and conduce real experimentation to create innovation. All these technologies will come with different data, and with mobile factors, mobile devices, hospitals, provider software, patient registry, and all government health plan. Pharmacy is very important, and we will see that in Indonesia, pharmacy and AI and e-health will evolve in this direction. All these organizations will generate data, and the data is the oil of this century, and we need to evaluate and create new service and new value from this data. As I tell you, for Indonesia, for example, for the future, for EI and e-health, we can see that the online pharmacy will progress significantly according to comparing with other sectors. For example, e-health device, we can see in blue here, not enough, but, and also e-health application. I am really surprised by this e-health application. If I say e-health device, it's not, it use electronics, and we need very sophisticated technology and companies with very high experience in electronics. But e-health application, we need computer scientists in generally and doctors. And my exchange with Agos and the students, Indonesian students I have met, they have good background and they are good developer. And I don't understand why Indonesia is limited, is not developed well for in the future. This is just prediction. So I think it's interesting to analyze such kind of results and the projection on the future, and try to analyze and to define a policy in the university or in the department to participate to the development of the country. So this is the first part, which is my introduction. And now I just want to, we have said that artificial intelligence and in e-health, we need intelligent machines because we will integrate intelligence, artificial intelligence, we will integrate humans and so forth. I start from Alan Turing with computing and problem solving. That means that reasoning thinking means solving problems. So if computer can resolve a given problem or perform a given task, that means that the computer think. In fact, in philosophy and in more general thinking is not the case, but in context of computer science and context of computers, and also in mathematics, the vision is that thinking is problem solving. And generally, we have, it's not so far, mathematics and computer science are not so far from each other because, for example, I just show here, we have sets in mathematics A and B that contain given elements, and each set can be represented by a sequence. For example, the element 1 belongs to the set A. That's mean why I put here 1 in the sequence. The element 2 is not in A, so 0, 3, 0, 4, 0, and so until 7. 7 and 8, element 7 and 8 are in the set A, so I put A, 1, 1. 9 is not, so there's 0, and 10 is, so I have 1. It's not so complicated to map set with sequence and sequence with the set in a finite universe. And finally, computing with sequences, as introduced by Alan Turing, is doing some algebra in finite sets, because we can try to do the intersection and the union, and they can correspond exactly to the sequence that can be deduced by E, A, and or, the operator E and or in sequences. So we move from sets to set theory or computing with set to computable sequences. So we know, as you know, the Turing machine has symbols, states, translation rules, and so forth. So computers now can be used to compute with numbers. Let's consider, for example, the function f, which is the cube root of x. And the question I ask is, what is f, the 8, when x equal to 8? Of course, we don't need sophisticated mathematics or computation to find the solution. A human can say, okay, it's equal to y, because we know that a is 2, 3 exponent, and we use the rule, the following rule. So the cubic root of 8 is equal to. It's easy, and the human generally performs such kind of inferences, or I can call symbolic inferences and the reasoning to solve a problem. But unfortunately, it's not so easy, because in here, F21, we cannot apply these rules, and so we have some problem here. We can use some approximation, and we can develop some methods and define some algorithms and allow your machine to compute. If you want, we can return back to this. I have some programs and they can show you, for example, the Newton method to resolve such kind of problems. Computers alone is not enough. It offers the platform, electronic platform with processor, memory, everything. And we need to return back to the work of Mohammed Al-Khwarizmi, developed in the past, who introduces algorithms to solve certain problems in defined steps of calculation. And this is the basic of algorithms. And we have his book, Hisab al-Jabr wa al-Muqabala. And if I consider the function cubic roots of x, I can write, for example, this algorithm, which is known as Newton algorithm. And we have some begin while. Here I have a loop, and I continue with a is the x. I want to find the cubic root, and n is the number of iteration. And when we finish, I return a. So I have a loop here, and you can see that the algorithm, I am not writing in any given programming language. It's a human or natural language programming language. And after I translate this algorithm, which represents a method, and I must be sure that my algorithm is correct and is converged. That means that it stops and it gives the good result. And after I have to translate it in using given programming language like Python or Java or any other language. And after that, the computer can use this program to compute the cubic root of any value I give, especially 21. Now algorithms allow us to resolve a problem, but we must know the different steps. We must know the method how to resolve. Artificial intelligence will introduce another way, like learning. That means that machine must learn. That means make useful change in our mind. That means we say that machine is intelligent if it behave or resolve a problem as an intelligent human. So there are different definition for artificial intelligence, and here are the father of this field, and especially John McCarthy. And all the work of this person and others leads us to what we are developing today, what we can call neurointelligence. Why this intelligence is neuro? Because the algorithm we are proposing and developing and the method and technologies are task-oriented. That means they deal only with one task. For example, Google Assistant or Google Translate, for example, it's only for translation, but they cannot do other things, for example. And generally, if we can remark that machine understanding speech and text in natural language, the analysis of speech and text is really the base of a lot of application and technology which is developed and we can buy in the market today. However, in the program, we have to interact with human in a personalized way. Where we are going to what people say general intelligence. Hello? General intelligence means where machine perform as better as human. More than that, that machine and human can work in a hybrid team to resolve a problem. Like human, we are in group and we try to resolve a problem together. Now we want to integrate machine with us and we collaborate together to resolve specific problem. It's possible, it's not, for example, if you think to airplane today for traveling, of course, there are collaboration between human and the machine to perform the task traveling. The problem of that, if a human collaborates with machine, a human think, and the question, the philosophical question, can machine think? I just want to underline here some rapidly, it's the only slide about this, the work of René Descartes about discourse on methods. And he underlined that machines would lack general reasoning abilities because they act not through understanding. However, human acts through understanding. Also, Leibniz remark about universal language, and he say an artificial language composed of symbols, concepts, idea, and logical rule for their valid manipulation. This is to imitate human reasoning. Of course, we have seen and we have introduced Alan Turing, machine Turing, and his imitation game. And finally, and John McCarthy, or can say the father of artificial intelligence, who say that machines are limited because their relation to the world is almost non-existent. In fact, a human perceives the world, but machine needs that we describe the world. And we describe the method to resolve problem, and then they can apply. This is a big problem, and I think that we need that machine now must perceive their environment, their work, and develop something which like a human personality, and next they can collaborate with the human. I think it's interesting. There is work, but I cannot discuss here. If somebody is interested by this perception-based research, you can contact me and we can discuss about it. But in practice, we discuss, and generally we are aware about machine learning. When we have application, we have data, and we want to do artificial intelligence method today, we apply, we develop a machine learning algorithm. That means we, for example, look at here. I have some information about my environment, the outlook, temperature, humidity, wind. And I want to know if I, according to these features, if I can play tennis or no. So I asked to some persons here, 40 persons, and the first he say, okay, if the outlook is overcast, the temperature is hot, and the humidity is high, and the wind is false, yes, I play tennis. And I asked to the others. My question is, can you, from what, can you define when can I play, when person play tennis or not? This is well-known example in machine learning, and we use it for course in the for beginners to show that this is the data, and we use machine learning that define or induce a model, which is here represented as decision tree, as a tree. So we summarized all this data in a model, and this model can be understood by human, because I can say, okay, person play tennis when windy is false and the outlook is rainy, or only when the outlook is overcast. And again, when the humidity, when the outlook is sunny and the humidity is normal. So I have summarized and answered the question, when can I play tennis? More than that, machine and computer can use this tree, this decision tree, to make inference. We say this model, to make inference and to, in a given situation, to say, yes, you can play or not. So this is a basic idea behind learning. We don't know the algorithm. We don't know how to decide if we play or no. We have no instruction and loops. We have no algorithm. We have no method. So we will observe the data. We learn from the data model, and then this model can be applied. It's more interesting when we have here, the example is easy because we have just few attributes. But if we have thousands of attributes and a million of instances, for example, a human cannot manage such data. So using machines and machine learning is really can be useful in this situation. I repeat, where we have no method to resolve our problem. In machine learning, there are several approaches we call the supervised learning. In the situation where each example in the data set, we have the correct answers. If you can see here, for this, the first data set, overcast, host, high, false, the answer is yes. So I know the real truth. And also there is, in this supervised learning, there are two things: regression, where we predict continuous value output, and classification, where we predict a discrete value output. If I turn here, what I want to predict is discrete value, because there are only two values, yes and no. Okay, so this problem I am solving here is classification problem. Okay, and supervised learning is different. We have data without labels. That means I give you the same data, but without this column. And I say, okay, when I play tennis, it's more hard, but we can do, the question is, can we find some structure in the data? The answer is yes, we can do, apply, for example, some clustering technical and algorithms. I just want to give another a simple example concerning linear regression to show what is the problem. And for example here, and to understand the technique behind, and just to show the difficulties and problems, we have supervised learning, for example, house pricing, and we would like to evaluate or to predict the price of a house according, for example, the number of rooms, the surface and the size and the position, the geolocalization, and the different aspects. This is a regression problem. And we have features that describe a house, and the output is the value of the house. So as the value is a continuous variable, so it's a regression problem. The data describe the house and why is the value, the price of the house. The question is, we are looking for a model or a hypothesis H. Here we are looking for univariate linear regression or regression with only one variable. That means I will know only one feature of the house, and they will predict the value. So we are looking here, the price is Y, given the future X. What we are trying to do in a linear regression is to consider that the hypothesis we are looking for is linear and writes as theta 0 plus theta 1 times X, where theta 0, theta 1 are parameters of the model. And the question is, given this data set, we have to find the best value of these parameters in order that the hypothesis H theta fit as best as possible our data. Okay. Now we define a cost function, which is for each, for example, for xy, xi is, for example, a future of a house, the house I. I use the model H theta, and they have a value, and they compare it with the real value as I'm in supervised learning, okay? And I try to make this difference as small as possible, as small as possible. So this function, minimizing this function, G, and allow me to find the optimal value of theta 0, theta 1. And so I will define the hypothesis H, the best hypothesis H, okay? I will just show, generally we use the gradient descent algorithm, which is general algorithm. In order to minimize G theta 0, theta 1, we start by some value, and I will show you an example, and it's very important from where we start. And we keep changing by giving equation to reduce G, to minimize G, until we find the minimum. Just look at this. For example, here I draw the function in 3 dimensions, where I have theta 0, theta 1, and the value of G. And here is, for example, here is when theta 1, theta 0 is equal 0, and theta 1 equal to 0.4, the value is this value, okay, of G. So consider that we start from here, theta 0, theta 1, and now I am going the making loops and continue. I find the next point. I continue, and so hopefully I can see here that I found the minimum value of the function. Of course, here I can, if I change the point and they start from another point, I will be in another optimum, which is not for necessarily the most optimal one. Okay. This is just an example of linear regression, but machine learning, there are a lot in supervised learning, there are a lot of algorithms around classification, regression, decision tree, and others, and also in supervised learning and reinforcement learning. How? And one problem is, generally, when you have the data, you have to split your data into training, validation set, and test set, and to improve and to construct the best model as best as possible. And also, generally, the model you construct, there are some what we call underfitting and overfitting. For example, if you consider this one is underfit, that means it doesn't separate correctly the data. This one is okay. This one is better because it's exact model, but it's complex model. And the more the model is complex, more the computation is also will be cost will be very huge, and we will need a lot of computation. So in generally, we have to manage and to try to learn, a model which is appropriate to our data, avoiding underfitting and overfitting. And all these things, of course, there are some techniques. We know the size of the data, and we know also other things about it. Generally, if you use scikit-learn, there are something how to choose your algorithm or the algorithm you want. More than that, machine learning is today just one part of data science. Data science is, of course, computer science, machine learning, but also mathematics, especially probability theory and statistics, also linear algebra, and also, at the end, domain expertise. For example, here I can consider medicine if we are about e-health. So data today is the new oil of the 21st century. And it became very important, and data is changing everything, and everything change and try to develop methods in order to solve problem driven by data, by observing data, and not by giving a method or algorithm. Artificial intelligence in healthcare, just to give some, to show the interest really in this field. And we are moving from 4.9 billion USD in 6 years to 150 billion USD. So the evolution is really very high, and there is a lot of things to do. And I think university can, and the research in the university and the research lab can participate with companies to this evolution by creation and innovation. Of course, the problem is hard, it's not so easy, but we don't need to deal with all problems for artificial intelligence in e-health, because the ecosystem is very large, include artificial intelligence, natural language processing, the Internet of IoT, of things, or medical things. There are learning robots, of course, blockchains, big data analysis, sensors to get data, and also data as platform is also very important, especially when we are dealing with very large data set. So the ecosystem, but we need, for example, we are interested by blockchain system and e-health, it's enough, and we can work on this subject. Of course, applications are very diverse and different application we can develop. And I think patient-facing solution for me is one of the biggest challenge, where human and the machine are combined together, work together to resolve problem and to deal with the health. This platform, just I gave you, and they are the reference here to show the interest of this figure is that it shows that the patient and the doctor can communicate together, not using mobile, using machine learning, reasoning, natural language processing, knowledge-based system, and more than that. And using chatbots today is becoming very universal to communicate and to exchange with, for example, doctor. Now I want just to give some application of AI in health, and just to point, for example, pneumonia diagnosis. We have some images that result from, that represent lungs X-ray, and we have normal the case and pneumonia situation. And the question is, if I have a new picture, how to decide if this image is normal or pneumonia? I have no algorithm, I have no methods. If I give this picture, this image to different doctors, maybe they can have different point of view. They can classify it maybe in different classes. So it's a hard problem. And as we don't know, we are going to develop a data mining, data observation and the artificial intelligence approach using data processing. Why data processing? I just want to say, for example, here I have pneumonia, more pictures, more images with pneumonia than normal. I have not enough, just few images in normal. And we need, here we have an unbalanced classes. I have two classes, but one, there are a lot of images, and we need to not to work. If we learn using this, all the data, certainly the model will not be very precise, very performant, because there is a dominant class. So we need to pre-process to select some elements and not to use in all pneumonia. And then after that, we use some learning here, for example, convolutional neural network model. And after, one important thing is the evaluation of this model. And we have some on the training set or on the test set. And after that, when the model is okay, I can perform some inference. I give as input to the machine a new image. And for example, here, machine tell me that it's normal. So it's very interesting approach. And it's not so complex. And today we can do this as a project, a student project without problem. I just want to introduce another problem about melanoma detection, which was developed by Agus Budiarajo in his PhD, and he has done a very good job with specific application, mobile application, where we just that embed an artificial intelligence or machine learning model, and then we give one way images. And here, for example, these images in non-melanoma with 23%, and this one is 92%. So strongly melanoma, and the prediction is done directly. So if you want more detail about this, you can contact Agus Budi. He's with you. Finally, I want just to introduce another application to show different things, heart disease, sorry, where we have not images, but our data is described as structured data by columns, describing the cholesterol, the sex, and different feature of the person, the age, the sex, and so forth. And we have this data. For example, we can see here that all the output is 1. Okay, so, and this one is 0. That means here this case are normal and this case are ill. And the question is, if I have one new person with the different value, what can I say? What, 0 or 1? So we have to do some data exploration. It's very important when we develop an algorithm of machine learning and we apply to e-health. We need to analyze the data not only as computer scientists, but we need to discuss with doctors about and integrate the knowledge. This is why it's hard, and we need to work with different persons. We can, of course, compute some correlation matrix to show if one variable is correlated with another or no, and also try to explain with the doctors and why this situation, why it's reasonable to consider that this variable is not correlated, is it normal or not, and how can we explain this? All this information today are, and if we need to develop e-health, AI algorithm and or solution, we need to work with doctors and to explain and to try to make intelligible our the element we compute using machine learning. And here we have what we call, if we use different algorithms, we can have confusion matrix with the different values. And in this situation, we can see that the different system, they give the similar results. The challenge, I have again 10 minutes, and this is the last part, the challenge for AI in health. The construct, of course, the device layer, where we have IoT element, velocity of the data, high velocity of the data generated by persons, and also large volume of the data, how to migrate, and especially we need to migrate this on different public or private platform on the cloud. So there is cloud layer, and these two parts, there are problem of security, problem of access to data, problem of updating data, and so forth. And this is another platform, another example where we have the same thing with different partners they participate, and they access to the platform. And today, such kind of platform, every country and government are thinking about, and they are certainly developing. And certainly in Indonesia, there are big projects on this. Of course, ethics is a big challenge, not only technological, because here a technological problem and challenge, okay? But we have ethics because we have some researcher, they use the data, individual, healthcare provider, and data analytics, and all this person, they access the data. What can we do with this data? How can we decide about this data? What are the limits? I think the problem of ethics is a large problem, and also it depends on, it change from country to the other, because person, they perceive ethics differently. I tried to find a general definition for ethics, and they say you have ethics if you don't do all what you can do. Sometimes we can do something, but we don't do it because we can say it's not moral, it's not correspond, it is not corresponding to my values. And ethics sometimes is when we don't do all what we can do, that means that we have some ethics which can be different from culture to others. Also, there is a big challenge between human and machine collaboration because there are diversity of users. For example, melanoma maybe is very important in Europe, but not in Asia or Indonesia, for example. The diversity, also the technology are changing very fastly, and the application are also evolve rapidly, and there are a lot of applications available today. And also the end user and human is very, very important problem. A human in the loop is a big challenge. And I just want to give you, and to finish with this example, is one project I am developing is about human AI collaboration, phobia of the dentist. What's this? This project, the beginning is the person, they have some experiences with their dentist, and they can fear of the dentist, especially when they are young, they are not very interested by that. And of course, sometimes we have also dentist avoidance because we don't want, and we are young, and everything is okay. And here we have some deterioration of oral health, loss of self-esteem, and finally, reinforcement of anxiety. This is a cycle for doing these things, and this cycle is repeated. And the question is, this person and the patient is very important in this process, and the dentist must pay attention to the feeling of the person, but how? Let's consider the same person who goes to the dentist, but now we have added sensors, and one of them is here, is used, well, the sensor will allow us to collect data, EEG, or brain waves, especially EEG. And now by using this platform, we can maybe separate between two visits of the same persons. How? Here we have developed a mobile application that integrates, that embed classification algorithm, In fact, there is not only one, but there are several algorithms. And I can see in this visit, the user, the user was zen. So it's, and here he is very stressed. Okay, more the circle is green, more the person is zen. Okay, so this dynamic board dashboard is drawn, for example, on a screen, and the dentist observe this during the session where he's trying to treat the person. And in this situation, what the dentist conclude that this user is there. However, in this situation, he is very stressed. And in this situation, I think that the dentist must maybe communicate differently with the user and try to integrate the user in his process. So this, I will not give more detail about this, but if somebody is interested, we can exchange the general architecture about phobia of the dentist. We have a dentist patient, and they are in the dentist officer with artificial integrated AI, which is integrated in a mobile, or in fact in now we are working with some dentists. They have a screen, and they can when the person enter, they put the sensor on his head, and they can start collecting data which is stored, and now we are comparing the experience with different persons. This is general idea, and of course this network can be, that means that the user can access to his work to have an idea about his experience when he visited when he goes to the dentist. I think it's 9:89. It's time for me to stop. Thank you very much for listening, and I am ready if you have any question. Thank you very much.
Thank you very much, Mr. Kwakaku, for your excellent presentation. Maybe we can give applause reaction.
I stopped sharing my screen.
Okay, thank you very much. Okay, before we continue to the question answer session, well, I would like to introduce that in ITS, we also have Excellence Center for AI, artificial intelligence for healthcare and society. Well, and I would like to invite Ms. Siska Arifiani, one of the member of the Excellence Center. Hello, Ms. Siska. I would like to unmute. Okay.
Okay. Hello. Good afternoon, Mr. Agus Budi Harjo and Mr. Muhammad Kwafau. Assalamualaikum.
Waalaikumsalam.
Okay.
Okay. So Mrs. Arifiani will introduce some of the works for the Excellence Center of AI for Healthcare and Society.
Oh, good.
Okay. I would like to share some project conducted by our Excellence Center. Wait a minute. Okay, thank you for the big opportunity, Mr. Agus Budi Raharjo. Yeah, Institute Teknologi 10 November have some excellent center. One of the excellent center here named IHAS, or we can call it artificial intelligence for healthcare and society. Yeah, this IHAS have a vision and mission. The first vision and mission is to becoming the center of reference for AI technology development in the healthcare sector to benefit society on a national and international scale. And the second is producing hardware or software products developed based on user needs or demand while collaborating with the people and the government alongside with small and medium business industry. Now I'm going to share some of our projects, some of our research, from IHAS. The first is computer-aided diagnosis system for osteoporosis. This system is used to measure the mandibular cortical width on panoramic radiograph in osteoporosis diagnosis. Automatic measurement of cortical width may enable us to identify a large number of asymptomatic women with low BMD. Initially, oral radiologists determine the region of interest based on the position of mental foramen. Some enhancing image technique were applied so as to measure the cortical width at the base point. Our new system may be used for mass screening of osteoporosis. This is the interface of the application. Okay, the next is Medcap. Now, the Medcap motion capture for medical rehabilitation. This system is used computer and Kinect stereo vision camera. This research team designed a 3D physiotherapist application that works by capturing image using two different viewing angles. The depth camera is used to determine the depth distance of the object from the camera, while the RGB camera is used to determine the shape of the object's texture surface. This Medcap motion capture is used for medical rehabilitation. Not only this Medcap, in our laboratory, I am the member of a laboratory in informatics department. The name of laboratory is Graphics Interaction and Game. In our laboratory, we also have some final project of our student. It is about post-stroke rehabilitation by using different device. It is similar device like this one, but we use a different device. We use stroke patient. That's it. Not only Medcap. And the next is TB analyzer, smart device to count TB bacteria. Oh, sorry. This device, this device is used to this is an automated system to distinguish between single and multiple tuberculosis bacteria and non-bacteria. We can in this research, we compare method backpropagation and Kenner's neck bore. Sputum sample digital image are converted to HSV color channel. The bacterial length and bacteria endpoint is a feature that is extracted from tuberculosis bacteria. This unique feature is used to classify which one is belong to single bacteria and which one is included as double bacteria. And then the next one is RISA. This one is robot for medical assistant. RISA is a collaboration between ITS and Universitas Airlangga Surabaya. This is a health service robot to help and minimize the contact of health worker and with corona patient. RISA is designed to be able to send various patient needs, ranging from medicine, personal protective equipment in the form of face shield, food, and so on. In the last version of RISA, we can only deliver what the patient needs. And in the next version of the RISA, we are expected to develop like a chatbot technology. So the RISA can communicate with the patient when they deliver develop in the next version of the RISA. And then I am the one of the for people with disabilities, such as art show or maybe training for people with disabilities and etc. By having collaboration between ITS and Komunitas Mata Hati, we are expected to help Komunitas Mata Hati and provide technology to help people with disabilities. Our first project with Komunitas Mata Hati named Listen App. Yeah, this application began in 2021. Yeah, when one of my student, yeah, in my course is disability. Yeah, for the first time, she joined my class. I don't know that she deaf disability, but after I give my student assignment, then the student need to present the result of the assignment in front of the class. I know that she is very special because she have a deaf disability. Then after the class, when the class end, I have discussed, I have a communicate, yeah, like have a talk, yeah, heart to heart with my student, and then she tell me so many things what she needs. So I propose this Listen app. Yeah, this application is one of the final project of our laboratory. Yeah, application for disability. This application is used to translate, yeah, text to speech and speech to text. Not only that, this application can be used to record what the people talk in front of them, and then translate it, yeah, by translate it into what is that, sign language, so the people with disability will understand and communicate well with the other people, with the other normal people. Yeah, this is some of user interface of Listen app. Yeah, and this is some of documentation. Yeah, when we try to conduct survey in the Komunitas Mata Hati, the challenge when we conduct survey in this community is how to communicate with people in disability, in the deaf disability, because people with deaf disability, when we talk to them, they will have a different perception. Yeah, because they have a limit vocabulary when we talk with the other people. So we need to use what is that, a common word, not a difficult term to communicate with them, so they will not be understanding when they communicate with us. Yeah, this is one of the documentation. This is very challenging for us to extract the information from these people with disability, because yeah, they have a disability, they have some limitation to interact with the application, and then they also have what is that, different limit in the vocabulary to communicate with us. So yeah, this is a big challenge for us to map their requirement, yeah, into the application. Besides this project, we also want to help Komunitas Mata Hati to develop their website. Yeah, if you search in the Google, yeah, Google Komunitas Mata Hati, they have a website, and the website is, yeah, the user interface is, yeah, not user friendly, I think. This is the challenge for us, how to develop a website that have user interface, yeah, that have user interface, that have a user interface that can be sorry, I'm going to revise my sentence. Okay, this is the challenge for us to develop a website application to help people with the disabilities can interact, can have a can interact with the website, so the website can provide information that they need, yeah, for people with the disability. Yeah, for the example, people with blind people, yeah, for the example, for blind people cannot read because they have impairment with their eyes. Yeah, so how we can provide information in the website so people with blind, yeah, can read, can understand the content of the website. Yeah, this is the challenge. Besides, some of our friends in this community, yeah, in Komunitas Mata Hati, they can use handphone, then they can use Android phone, although they can see the monitor, the screen of the phone. Yeah, they can interact with the handphone by using gesture. Yes, not a gesture, what is that, yeah, yeah, some gesture, and then what is that? Speech recognition, yeah, speech, something like that, to interact with the application and use some application in their handphone. Now, this is the challenge for us to provide information in the website, and so people with the disabilities can interact with the website, can use the website, yeah, have a user-friendly user interface, yeah, have a user-friendly interface, so people with disability can interact well with the environment there, yeah. Besides the last project, yeah, not only Komunitas Mata Hati, our IHAS also have a collaboration with BPJS, yeah. BPJS Kesehatan is a health insurance, yeah, in Indonesia, one of health insurance in Indonesia. Some weeks ago, the IT manager of BPJS come to our institution and they say that they have a data, they want to our member to process or manage their data so they can extract information or maybe knowledge from their data. Nah, this is our challenge. Then this project will be really soon, and we still running, still ongoing, yeah, for this BPJS project, and the result will be informed next in our IHAS website. Yeah. Maybe that's all for our presentation. Thank you very much for the big opportunity, Mr. Agus Budi Raharjo. Yeah, thank you very much, ladies and gentlemen.
Thank you very much, Mrs. Kariviani, for presenting some of the work of Center of Excellence of AI has. Okay, yes, I think Mr. Kafafu, I think we have to return back to our research because there are some perception things or some interesting topic in AI.
Yeah, thank you for Professor Siska Arifiani, is it? For your interesting projects. And my question, I have question about perception.
Okay.
If we consider cultural difference between persons, translation is not the same, and the way to express something when we are happy change from country to other, from culture to other, and behavior, how we behave is quite different. So we need to integrate. And if I, during my presentation, I introduced computing with numbers using computers. But Lotfi Zadeh from Berkeley University introduced 20 years ago computing with words, which is very important. That means if I say he is tall, what is meaning? How to understand me tall? It depends countries, it depends a lot of things, it depends what we are. We always compare with ourselves or with our friends or with our environment. And there is a third part, a third way. During the PhD of August, we have discussed it, but we have not enough time to work on it. I have developed different things about, and now is computing with perceptions. That means we need a theoretical foundation for what is perception, like mathematical foundation. What is perception, and how can we compute with perception? I think there is a way to develop something. I started doing this several years ago about set theory, and I introduced some notion about indiscernibility and accessibility and all these things. My theoretical can allow us to develop some method and algorithm to show that we have different perception of the world. Or one question is, if you invite different person for example, dinner, they come from different countries and they have different religion, different belief, different, they have different experience of food. The question is, what meal can I prepare in order to allow different persons to be happy and to find what they want. It's quite hard, the problem. And this we can develop some algorithm. I have developed a new algorithm about using hypergraphs, and can do some computation to find some space, research space, which give solution where there are solutions that allow everybody to be in the loop of the dinner and not to be excluded from the dinner. So we need today to understand this and to try to develop this cultural difference, this different perception of the world, and different decision. That means the problem is that machines are what I say living, they are living in true or false. That's all. But we human, we accept inconsistency. Sometimes something is okay, true for me, but after it's false, but it doesn't matter. I live with, because machine cannot, if something is true, it must be true. So they are living, what I say, in the paradise of Hilbert. Everything is consistent and everything, there is no contradiction, no inconsistency. If something is true, I can prove it that is true. But something, for example, I always ask for given president to different person from the same country, is it good or no, your president? But they have the same age, they are my student in a master, and they say yes, and the other no. But I think it's not, it's the truth of everybody. So truth can be relative, and we can try to do some inferences by relative truth instead of absolute truth. Just a small introduction, but I would be happy to share this with you if you have time and if you want.
Thank you very much, Mr. Kwapaku. Okay, so now we are going to the interesting session. So the question answer. If you have any question, please raise your hand. Okay, is there any question? Okay, while waiting, I would like to ask a question for Mr. Kwapaku. So we regularly get a question about the ethical in health, to apply AI in health, and it's a quite big problem in Indonesia. Well, quite not problem, but a big challenge in Indonesia. So what's your experience maybe in France? Is it easy to proceed, or there is a long procedure from the ethical?
I think there is, in everywhere, all countries, it's a challenging problem. And I know that United States, and I have some friends working, and in North America in general, working on this subject. It's quite a difficult problem because we don't need only to define what is ethics. We need to translate it in a law, and we need to apply it. So it's not only, and also it's depend not only on the law, but on civilization and our inheritance in each country is quite different. And what we want is to find the universal ethics. So it's really difficult. And I discussed with a friend who working in Canada on the subject with collaboration with Google. And the difficulty is how to translate the definition we have in a law, and how this law can be well understood by citizens and accepted on not only the citizen of a country, but all the world. But we know it's a dream to think like this because people are different. If I show you something, an apple or a banana, I say which one do you want to eat, people will not choose the same thing. So we know that we will not be agree about. This is why I arrived to this pseudo just definition to say the question if I am ethic is if I have ethic or no. And I can answer myself if I do all what I can do, I have no ethic.
Okay.
So sometimes we have to stop. So maybe ethic can be adapted from country to others or civil or cultural inheritance to others to say, okay, the most important is we don't do all what we can do. Okay. If, for example, I am walking and there is open car and there is a camera, I can say, okay, and there is no person here, no, I can take the camera and go with, okay, I can do it. There's no problem. My brain, they told me there is no risk. Okay, but maybe I can say, no, I cannot do it because it's not mine. This is, if I don't do it and I go without, that means they have ethic. So the first, I think the first thing to put in ethics is in the person himself, if he can do all what he can do or not. And after, when we are agree about this general definition, we can start to say, okay, we can disvalue, for example, don't take things which are not yours. If we apply this in country, it became an accepted value by all citizens. And after, we have to define all these values, all these accepted value. But we must be aware that maybe these values can change from country to other, depending on the context, depending on everything. It's normal.
Okay, thank you very much.
But there's some work, if you are interested, I can send you some idea about, or some references. I don't know if he has finished his research or not, but I can ask him about, but there are some work on this, general works. And for me, the idea is not just to write a paper and we have ethics. For me, is to transform this ethics to law, and this law is accepted by persons. So we need the process to create ethics together. We cannot just think in the government and say, this is the ethic. It doesn't work like this.
Okay.
The ethic and value of ethics come from citizens and are accepted together by citizens. In general, maybe there are some persons they don't, but in majority, they accept this value and they apply it, because there is a big difference between accepting the value and applying the value in our life. Okay, and the ethics is really well defined when it is accepted, transformed to law, communicated to all citizens, accepted, of course, by citizens, and applied by the majority, the big majority. If we arrive to this process, yes, we have defined ethics.
Okay, thank you very much.
It's my opinion. Yes. It's not.
Yes.
It's informal opinion. So I'm not
that's very
expert in this domain. Just I give my opinion.
Okay, thank you very much, sir. So we have one person who raised hand, and we have two questions. Maybe I would like to invite Putu Krishna and Yarta. Please, if you have a question. You can unmute right now. Okay, you can.
I have one question.
Hello, sorry. Can you please hear me? Okay, thank you. Sorry, I wasn't allowed to turn on my mic. Okay, thank you very much for the opportunity, sir. My name is Krishna. I'm a student, undergraduate student of informatics and ITS. So I have a question. It might be related to what was asked by Mr. August previously. So when the society already accepts AI role in health, do you see that AI could replace medical workers in the future? It's like maybe we already see AI replacing like economists and accountings, but would you see AI fully replace doctors, nurses, and the like? Thank you. That's my question.
Okay, thank you very much. This is big question, and all people generally ask that AI will replace humans. And it's normal to think about this. And I just give an example in the COVID. Voila, I give this example to be clear, or to give an example to illustrate the answer. During the COVID, hospitals, they receive a lot of persons who want to be controlled if they have, and check if they have COVID or no. The human resources are not they are not sufficient or enough for dealing with all these person in a reasonable time. So, and also there is a risk if nurses and doctors interact directly with large people, they come to the hospital. In this situation, there are some hospitals, they have used AI experiment to predict the risk of a given person. So a person can try to enter in a computer the input, answer some question, and then there is a risk evaluation of this person, which is predicted by AI. And by doing this, we have ranking of this person. And after that, of course, we have to deal and to meet and to treat all persons, but just the most critical situation. In this case, we cannot be played by humans. Okay. Another example, for example, in the airport, when we arrive and there is a lot of persons, they arrive, lot of planes, they arrive at the same time, and there are thousands of persons in the airport, they cannot check it by human directly. Even if we have 100 persons, it's not enough. You must wait maybe 4 hours or more than that. So there are some airports, they have put some camera and some devices where you put your passport and your fingers and the other things, and they decide, okay, you are right or no, and after you go, and it's very fast, I know it's complicated because there are some persons, they are not able to use or understand how to use such kind of systems, but it can help. Yes, of course, maybe sometimes. I think the work will change. The organization of the work will change. The introduction of AI will certainly change the process of the work. And of course, people can play different roles, not necessarily the same role. But I think it will be benefit in the future to use technology and to use it correctly, because we are living in a small world. People can move directly from one country to the other, and we can see that in the risk situation, we must process rapidly information, and we must take decision rapidly. We cannot process only manually the information. We need computers and we need prediction. If I told you, I show you the example of data to play tennis. If you have 1 million person with 100 futures, and they give you the data on a file, and they say, oh, okay, and they have 1,000 person, they are analyzing this data, tell me when to apply. We cannot. So I think we are moving to a new society. We are changing the society, and it's normal. There is Mohammed, and I don't know if I have answered your question or not. Mr. Potu?
I think it was answered perfectly. Thank you, sir.
Okay, thank you. There is Mohammed
Thank you.
Iqbal Abibi.
Yes, I think
Yeah.
there is a previous question from Zulfikar.
Okay. Okay. Machine learning. Oh, yes. Is it the question about privacy of the data? So if I have personal data and they want to share it, maybe it's problem, there is problem with the security of the data. Is it?
Zulfikar?
Yes, that's right, sir. My question is about the safety about the data.
Please repeat, I don't listen.
Can you repeat it again?
Please.
Yes, that's right, sir. My question is the safety of the data. Thank you.
The safety of the data.
Because I think yes, it can take a lot of the data, but if you there are we are working today with platforms. So this platform, every day you use it. So if we look at, for example, look at your what if you use any application of your mobile, and at the end of the month you have generated a lot of data without a very significant data set, and we can have clear idea about where you go, what you eat, what you buy, and so on. So the problem of generating the data is not a real problem, because today with sensors, when we move, we generate the data. When we pick, we generate the data. When we phone, when you spend, for example, if you use Twitter or WhatsApp, when you send messages, you generate data. And at the end of the month, there are a lot. The problem is that each person today generates a lot of data. So it can be used by, just by the way, I am developing an application with the mobile that collects, my idea is that my personal data will be in my mobile phone, and it can be shared with others in an anonymous way, or can be integrated also in anonymous way in a platform, AI platform on the cloud, to define and to learn more about. For example, there is a website called, I think, Patient Like Me. If you go there, and you will find, for example, if you have some symptoms, you write, and you can find some person, they have the same problem, the health, and you can discuss with them. You can visit and share how they have evolved, which kind of treatment they have used, and so forth. So it became very interesting in sharing information, but also experience about health.
Okay, Zulfikar, is that
Okay. The answer is very clear. Thank you. It's answered my question. Thank you.
Thank you very much.
Thank you very much, Zulfikar. Mushu, I think we have, well, it's getting more interesting. We have One question on the chat and one person raised hand. Maybe we can wait from the chat first. From Muhammad Iqbal. Hello,
Iqbal,
Muhammad
okay.
Iqbal.
Yes, the question about the data storage.
So it's
I know it's very important and we have a lot of data. I just want to give another example to show and to illustrate my answer. If you have information in a country is about, like, for example, in French, the country, the region, the department, the city. So there are different levels of hierarchy. And generally, we don't store all the data of the country in the same database. Generally, we organize the data hierarchically if possible. For example, all the data of a city, like for example, Marseille, and this data is also included, indexed in the data of region, and after department, and after the city of France. So the data is stored at the low level of the hierarchy, which here the city. We can consider organizations like universities or public, and after they are indexed in other more general database, they are only indexes. So we can store the data in different server, and after we have the query can be processed rapidly, even if we have very large data set. For example, if you use MongoDB, I think the technique is called shading. It's allowed to define different servers with different API, and they are stored hierarchically, and they are indexed, and the query is very fast. We have developed the system like this and experiment, and it works with million and million more than we have more than 10 million persons and in our website, and we have directly the information about the person in less than 1 second. So it's we can allow us to store big data sets. There are also some solution developed by Google and by Oracle and by other database operators. And I think they are, I experimented with MongoDB, and yes, we have distributed our database. It's just technical problem. But of course, when you have large data set, you have to pay attention to this issue.
okay. Hello, Mr. Muhammad Iqbal Habibi. Is it answer your question?
Yes, because our data set is a little bit large amount, so I was wondering what technology will be stored to put this like a machine learning and AI. So thank you. Maybe I will try some like open source, maybe like MongoDB and so on. Okay, thank you very much.
Okay, I put in the chat MongoDB sharding from the exact lecture. So you have to just to understand this thing, how they are distributed with different IP, and it's well defined. There is no problem. You take tutorial about sharding, and you will see that your system will be efficient even if you use very large data set. If you have any question after about this, when you experiment, you can contact me and they can exchange.
Okay, thank you. That's very good. Thank you. Okay, thank you, Mr. Muhammad Iqbal Habibi. I just remember when I was in Marseille, you built a data center in the ground level of a polytechnic, and then you apply SparkQL, Hadoop, and all the kind of distributed system and for handling big data. And that's very good resources. Okay, so I think we move on to the next question. So the last question, I think it's the last question because we already past the time. So Mr. Fitra Hari.
Ya,
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Thanks for the opportunity. Nice to meet you, sir, professor. My name is Fitra Ramadan. I'm from informatics, IPS. I have one question. If we have some data set, we must make it some model to after that we execute in machine learning, that. And I have some question how to optimize some model in machine learning as beginner like me. We know you're professional and I'm just beginner, and I want some suggestion about this, sir. Thank you very much.
Thank you. Nice to meet you too. And thank you for this interesting question, because we start always at the beginning as a beginner. And as I said yesterday to Mr. August, the beginning is hard, with the end also. So don't worry, difficulties is everywhere. But be happy, because we can try to find solution. And this is what's interesting. I think you can just learn, for example, linear regression. And you learn the linear regression. If you contact me after, I can send you some information and some tutorial about this. You need to have a clear understanding of the data, the model. I started with the G, with the optimization of the function G, how I transform the hypothesis to find the problem of finding the best hypothesis in an optimization problem of parameters, and after which algorithm I use, for example, gradient descent, which is batch algorithm because we use all the data. Maybe it's not a good idea when the data is large, okay? And we can, when I understand how it works, how the optimization became, I have some problems after with, for example, the complexity of the model. Yes, the model gives the good result, but it's complex to compute. Maybe there are some overfitting. So we can, and if we have a large data set, we can then try to resolve the problem by introducing regularization problem, okay? And after, when I have regularization, so all these steps, if you do it for only one algorithm at the beginning, you will have clear idea. And after, of course, things change from one to others. Unfortunately, I have no time, but we can explain how SVM supervector machine are related with regression problem. So if you understand really at the beginning the regression, linear regression, you can but understand, not only apply and take code and it works. No, understand and take time to understand step by step why I use, for example, logistic regression, why I use polynomial regression, how I do regularization, what is the effect of the parameter of lambda of the regularization. If you spend time understanding these steps, I think you will have clear idea, and you will see in the future that if you change the regression, and for example, you consider a super vector machine, you can understand and you can manage and design, because there are some tips and some recommendation how to design well a good solution based on machine learning. Okay. So sorry for not giving a solution with 1, 2, 3, 4 to do. I just enumerate some examples, but you contact me and I can send you more detailed information. But you need to spend time to understand, not only to apply, please. Okay.
Okay, thank you, sir.
Okay, thank you very much, Mas Fitra. It's from our student informatics department. So I think because we have a limited time, I'm very sorry for other question. It's thank you very much, Mr. Kwafafu, for answering this question, for presenting a very excellent course material, and it was a pleasure for us to have you. And so I think maybe we will continue with research collaborations and propose, etc. And maybe some students over here, if you are interested, maybe you can contact me or contact Mr. Papaku.
Yes.
Have maybe a master degree, doctoral degree, or even your final project of undergraduate, because we have several research to do.
Yes,
Okay.
there are students, they can contact you because you are there, and I work with August, and we are always exchanging information. If you have any question, you are welcome. I will try to do my best to answer. I'll try to look to answer your question. And thank you for listening. Thank you, August. And I hope that we can continue collaborating because there are a lot of things to do.
Okay, before we close, I think, can we take a picture together for participant? Maybe you can, yes, you can open your video so we can see not only your name, but also your face, etc. So if we meet outside, maybe we'll know. Okay, so I'll take a picture in 3. So we have 4 pages. Actually, totally we have like 120 participants, and now it's like 89 participants. So, okay, let me count. 1, 2. Sorry. 1, 2, 3. Smile. Then 2, 3 from the 3rd page. Smile. 1, 2, 3 for the 4th page. Smile. Okay, thank you very much, Mr. Kwahohu, and all participants. It's a pleasure for us for having you in this excellent session. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. And bonjour. Bonne journée à la prochaine.
Bonne journée, merci. Au revoir.
Merci, un grand merci, monsieur.
Assalamu alaikum.
Waalaikumsalam. Okay. So I think that we will end the meeting in 3, 2, 1. Bainka, please.